So there's something I always like about this chapter, and it's mostly that it's divided up into little bits. And I think that these last two sections, the 1.6 and the 1.7, are also nicely divided up so we can kind of focus our attention. So we've gone through this transition to algebra, talking about a lot of different things, but we are working our way to some of this literacy in algebra. So we've talked about how everything in chapter 1 is about expressions and what expressions are. We've talked about variables, and we've talked about a lot of things. So the next thing that we're going to talk about are terms. And we're going to go through adding, subtracting, and then multiplying and dividing terms. And so multiplying and dividing is the 1.7. And so before we get into all the operation with terms, we need to figure out what the heck a term is in algebra. So what a term is a number or the product, and again that implies multiplication, of a number and one or more variables raised to a whole number power. So we're going to have numbers, letters, and exponents in all this. So that's what we're talking about, power here. We're talking about exponents. So as an example, these are all terms. So this is a number and a letter. And as you can remember, when two things are smack up beside each other, that implies multiplication. And this is a perfect example as to why we wouldn't write it 3 times x, because you'll go nutty trying to make sense of that. Nobody's handwriting is generally neat enough to make some sense of that. And so 3 times x is written as 3x. If we were to dissect this a little bit more, these are all terms, and we'll go through them all. The number out front, so that 3, the whole number here, is a coefficient. So any number that's out front is a coefficient. It can be, actually, I said whole number, but it can be a fraction. The letters are the variables, and we're used to those. And then we have the exponents up here. So in this term, we have a coefficient of 5, and we have 3 different variables. We have x squared, y cubed, and a z. Now, invisible on that z is the whole number 1. So we've had things that are invisible so far, but we're going to have a few more things that are invisible. So there's a 1 on that z. Similarly, there's a 1 on that x, because there's just one x or one z there. The other things that are sometimes invisible are a positive on that coefficient, right? If there's a negative, then it's written, but if there's nothing, then it's a positive. Okay, so moving on in other examples here, because some of these are a little bit wacky. Technically, 2 is a term. It's a number, or, right? And so in this one, because it says or, 2 is a number, and that makes it a term. The next example, negative 4xy. This time our coefficient is negative and is written as negative, so it's a negative 4 as the coefficient. And our 2 different variables, like I said, have that invisible 1 on them as an exponent. So, oh, I didn't switch to invisible color. The invisible color is going to be red today. And so those are invisible. The other thing that is invisible here is the coefficient on this last example. So this last example has an invisible coefficient of 1. And I'll try and reiterate any of these oddballs that, they just bear some notice. And I'm sure we'll get used to it as we move forward. So I've kind of gone through and for each example figured out what the coefficients and the variables are. And in this last case, 1 is the coefficient. Red seems really angry. I'm going to switch back to green. Okay, so in the expression, terms are separated by addition and subtraction sign. This is one of those things that, like, sub in with the brackets. The sign goes with the term. We're going to do a lot of work with terms in algebra, and this is always a good thing, is that the sign goes with the term. So we want to circle the terms in the following example. Well, A, that's all one term. B, because they're separated, we have a positive 5m and we have a positive 3n. I should have had that positive in there. My line was just a little bit off because that's the point of what I'm trying to say right now. D, I skipped one there. We have a positive 2s squared and a negative 3t and a negative 6. We actually have 3 different terms here. E, we just have one term. That one term has a coefficient in 2 different variables, but we only have one term. C is the oddball. So C is a term, but it's not in simplest form. And so that whole thing is a term because it's not separated by addition and subtraction signs. Now, it does have a negative sign, but just as we remembered, positive and negative in math and on your calculator is different than the subtraction button. And so keeping that in mind that they're different things, and we don't have a difference here. This is one term, but it's definitely like a trick question, I think. All right, so we're going to move on, working our way towards adding and subtracting terms. And in adding and subtracting terms, we have to talk about like terms or common terms or things that are exactly the same as far as the variables go. So I've talked before about how you can add 4 people and an apple, right? Those are not like terms. And so for them to be like terms, they have to have the variable part exactly the same. So this first one, this 3x squared y and negative 6x squared y, because the variable part are the same, that makes them like terms. Down here for B, so they have the same coefficient, and they have the same letters, but they don't have the same exponent. And so you are not allowed to add or subtract those. Those are not like terms. Moving on through here, C, we've got A's and AB's, so that makes them not like terms. You can't add or subtract those terms. D, we have 2x and 5x. Those are totally like terms because the variable part is exactly the same. And then E, coefficient's the same, but the variables are not. And F, a lot going on there, but they're not exactly the same as far as the variable goes. Okay, so combining like terms or adding and subtracting terms, you can only do the math with the coefficients, so add and subtract the coefficients, if the variables are exactly the same. It's also called collecting like terms. So the coefficients are added or subtract, and the variable stays exactly the same. Nothing changes. So it's kind of like you can't add apples and oranges, just as you can't add x's and y's. So let's take a look at these. Again, with these, we're simplifying these. These are expressions of multiple terms, and we can simplify them if they have like terms. We can simplify them by collecting like terms. That's adding and subtracting terms. So A says 9b plus 6b. Well, because they are like terms and the b is exactly the same, that allows me to say that is equivalent or simplified to 15b. The next one, if I have 5 qp cubed, that's fun to say, minus 4 pq cubed, the pq cubed part of it is exactly the same. That makes them like terms. So 5 minus 4 is a 1 pq cubed. So that one's totally fine as an answer. In the back of the book, it's going to drop that 1. It's invisible. If it's not written, it's understood to be there. And so your final answer would just be a PQ cubed. Either one is correct, though, in my book. Okay, so sometimes you have multiple terms and they're not all like terms, and yet they're all not unlike terms. And so sometimes you get this expression that looks like that, and you have to simplify it. So you identify the two like terms, and sometimes I go through and classify them with some kind of like check or underline system. And then I know that I can do those first, and I'm stuck. I can't add the 5y. So my final answer for this would be 6x plus 5y. And that's the best that I can do. That is that expression simplified. For D, again, I like to go through and categorize these. So I have some M terms and I have a couple N terms. If you want, you can rewrite them beside each other. I usually just do it this way, looking at the underlining system. So I have 5m minus 4m, so that would be 1m or just an m. And then I have 8n minus 3n, so that would be a positive 5n. So my final answer might just be m plus 5n. All right, so the whole point of this is that we are learning how to do math with not just numbers, but with numbers and letters. So we're going to move on and go back to that idea of distributive property, because we couldn't make them, we couldn't add them anymore. We couldn't use distributive property. Or sorry, order of operations. I was flipping in my notes and got distracted. Okay, so the idea here with the distributive property is that we're going to take 3 times the 4z, so that'd be 12 as the coefficients are multiplied times z, right? Or 3 times 4 times z. I simplify it to 12z. And then 3 times 5, so that'd be a plus 15. And then I'm rewriting this equivalent expression. I don't want to drop anything, so I just recopied the minus 9 out there. So now that I have it like this, I can take a look at the like terms. I only have one term that has a z variable in it, but I have 2 whole numbers out the back here. So now I can rewrite this in simplified form as 12z plus 6. And that's my final answer. Sometimes simplified isn't overly simple, but hopefully we're going to get used to having, a lot going on in our answer. It's always really nice when it works out to 4, or the answer being like 42. But sometimes it's a little bit messier than that, even though we say that this is simplified. Okay, so distributive property on the next one. 7 times 4x, so that'd be 28x. Because they're just all multiplied together, you can do that with the numbers and you just throw the x out the back because it's still multiplied by, even though you don't know what it's worth. And then 7 times negative 3, so a negative 21. And I'm just going to recopy this one, negative 25w. So at this point, I'm done. I can't do any more because I don't have any like terms. Now, there is a convention oftentimes, like I think that's fine, and that's what my key says. The book tends to alphabetize their expressions. So if yours are out of order, it's absolutely fine, so long as the sign goes with the term. And that's something I'm going to say like over and over and over again. So sign stays with the term. You can write them in any order. You could write them in alphabetical order. So you could do 28x, no, wx. So negative 25w plus 28x and minus 21. If there is no variable, it usually hangs out the back. So they're the same thing. Wx, okay, I was thinking and muddled on my alphabet. Okay, so this one has some distributive property. If we were to attack this with order of operations, we have to do what's in the bracket first here, but we can't. And so we bust open the brackets with the distributive property. I'm going to recopy the 5p, and then I'm doing this distributive property. So I have 4 times p, so a positive 4 times p, and a positive 4 times a positive 3, so a positive 12, and I recopy the 8 hanging out the back. So now I have some p terms and I have some whole number terms, and I can collect those like terms. I can simplify this expression further. So 5p and 4p is going to give me a 9p, and 12 minus 8 is going to give me a 4. And that would be my final answer for that one. There's a few more here to simplify, and I would encourage you to kind of use that kind of categorizing. So I have some m squared terms in this one, and I have an m term. If you like to rewrite them, go for it. Just make sure that the sign is sticking with the term, right? So in my mind, I just look across. So I have 11m squared. And if you like to check them off, you're like, yeah, I got that one. Then that's another system I've seen people use. And then I write minus 3m because it didn't have a counterpart. It didn't have another like term. Okay. Another one, and I have to kind of squint at this one. I have some A terms if I'm hunting in here. I have some B terms. and then I have some whole number terms. And so I circle or underline, color code, highlight, whatever it is you want. You can also, like I said, rewrite them so that the A terms are beside each other, the B terms are beside each other, but I tend to do it this way. And when you get a lot going on, it can be useful to kind of check them off. So we've got 4A minus 2A, so that gives me a 2A, and we've got a 7B and a 3B, so that gives me a 10B. Dealt with those, and now I just have the whole numbers to deal with. So I've got a 3 minus 2, it gives me a plus 1 as my answer. And obviously not very simple, a little simpler than what it had said, but it's still definitely not a single number. So a few more to do on these ones. Really, taking your time to read them carefully and make sure that they work out. You can check the key on this one, or we'll stop this and do it together in class.